Okay, so if you remember the other day, we did the long division. So here I have a question. We have a polynomial given, f of x, and the first thing it wants us to do is determine f of 3. So if you remember with function notation, f of 3 means just put 3 into the equation for all the x's. So we're just going to substitute in 3, and then we're going to see what we get. So we get 27. 9 times 6 is 54, plus 9 minus 10. And let's see, I just need to grab my calculator. Just let me grab my calculator. So we get 27 plus 54 plus 9 minus 10, and we get 80. Okay. The second thing it wants me to do is divide the polynomial by x minus 3. So if you remember, it's good review for long division. So long division, we're going to divide by x minus 3. And let's see what we get. So I have to multiply the first term x, and I have to get x to the power 3. So I would need to multiply by x squared. So x squared, remember we multiply. So x squared times x is x to the power 3. X squared times negative 3 is 3x squared. And then we subtract to see what we have left over. So 6x squared minus a negative 3 is like adding 3. So that will give me 9. And then we bring down the next term. Knowing that the first term will always add to 0, x3 minus x3 is going to be 0. Okay, so now we're going to do it again. So we have to ask ourselves, what do we multiply x by to get 9x squared? Well, we would need a 9 and an x. So we multiply 9x times x and 9x times negative 3. We subtract to see what we have left. So we have 3, and again we have minus a negative, so plus, so that's 30x. Bring down the last term, and then we would have to multiply by 30. So 30 times x is 30x. 30 times negative 3 is negative 90. Subtract to find the remainder. So we have negative 10 plus 90 is 80. So looking at what we got when we did f of 3, we ended up with the same result for the remainder. We ended up with a remainder of 80. So that's a coincidence or not? So let's do it with a different question. Here we have, so we're going to use the same polynomial. Right, we're going to use the same polynomial because we want to try it with a different number. So 6x squared plus 3x minus 10 is our polynomial. I get the signs right? Yep. So now we're going to do f of negative 2. So we'll put in negative 2 for each x. And let's see what we end up with. So that's negative 8. Negative 2 squared is 4. 4 6s are 24. Minus 6 minus 10. And if we add all that up, we end up with 0. Okay, and then we're going to divide by x plus 2. Okay, so we would need to multiply x by x squared to get x to the power 3. The 2 comes along for the ride, so 2x squared. And we subtract to see what we have left. So 6 minus 2 is 4. Bring down the next term. Now we would have to multiply by 4x. So 4x times x is 4x squared. 4x times 2 is 8x. Subtract to see what we have left. So 3 minus 8 is negative 5. Bring down that last term. and we would have to multiply by -5. So -5x minus 10 gives us a remainder of 0. And so looking at, when I looked at the first question, when I put in f of 3, I got 80, and when I divided by x minus 3, I ended up with a remainder of 80. If I put in f of -2, I got 0, and if I divided by x plus 2, I got a remainder of 0. So it looks like when I do the function notation of the root, I get the same answer as if I did the long division and I compared the remainder, right? So the root of x plus 2 is x equals -2. So if I do function notation of the root, right, -2, I get the same remainder as the function notation. The same with this question. The root of x minus 3 is x equals +3. And if I sub that into function notation, I got the same answer as the remainder. So let's do it one more time to see if this works with the next one. So f of 4. So if I have x minus 4 and I solve for x, the root is 4. So if I do f of 4, so here's the polynomial again. So we're going to do f of 4. Oops. My smartboard's acting up. Come on. Okay, just bear with me. My smartboard has all of a sudden decided to freeze. Okay, let's see if that fixed it. Nope. Okay, I'm just going to mute myself for a quick second and see if I can fix this smartboard. Okay, so it looks like something went wrong. We're trying to get you back in the meeting. Okay, so we're doing f of 4. Grab my calculator. And so 4 to the power 3 is 64. And then we have 16 times 6 is 96. Plus 12 minus 10, so we'll add this all up. 64 plus 96 plus 12 minus 10 is 162. Okay, now I'm going to do synthetic this time because I've done 2 examples of long division, so let's do synthetic. So synthetic, remember that we only use the coefficients. We don't worry about the variables. And it's just a quicker way. So variables or coefficients are 1, 6, 3, -10. We bring down the first number and we divide by the root, not the x minus 4. We divide by 4, the root. So remember, we multiply. 4 times 1 is 4. We add instead of subtracting. Then we do 4 times 10 is 40. We add, and then we do 4 times 43 is 172, and then we add. And so that last number is the remainder. Okay, so again, I see this number here, 162, is the same as the remainder. So this is called the remainder theorem. So the remainder theorem says that if you have a polynomial and you divide it by some factor x minus k, so k is a number, the remainder will be the same as putting in the root k. So for example, if I divide by x plus 2, the remainder will be equal to f of negative 2. Okay, so solving for the root. And the second part is just if you had a coefficient. So jx minus k. So for example, 2x plus 1. If I divide by 2x plus 1, it will equal the same remainder as f of negative 1/2, right? I solve for the root, so 2x plus 1. If I solve for the root, I would get negative 1/2. So that's all that means. So the remainder theorem says you're going to get the same remainder if you divide by the polynomial. If you divide the polynomial function by x minus k, you will get the same remainder as if you just put in the root into the function and determined that value. So that's a quick way to find the remainder without doing the long division. Okay, so if I get a question like this, what is the remainder if we divide the polynomial f of x by x minus 3? And I didn't want to do that long division or that synthetic even. I just wanted to know what the remainder is. So if I only want the remainder, I can solve for the root, and then I can just do f of 3. So f of 3, I just substitute it in to the polynomial, and we get 9 4s is 36 minus 15, and what does that add up to? That adds up to 48. So that means that if I divided f of x by x minus 3, the remainder will be 48. And if that's all I want to know, I can just do this function notation, f of 3. And that is useful if I want to know if something is a remainder. Okay? So this one says determine whether 2x minus 5, actually let's skip to this one for a minute. No, okay. So determine whether 2x minus 5 is a factor. Well, this leads us to the factor theorem. Where's my notes here? Okay. So the remainder theorem says if I sub in the root, I get the remainder. If that remainder is 0, that means that we don't have a remainder, and so that binomial must be a factor. So this is the factor theorem. So the factor theorem is sort of continuation of the remainder theorem. Okay, so if x minus k is a factor, then f of k will be 0, meaning there's no remainder, right? We have nothing left. And so that is helpful when we are factoring. If we can find a number that gives us 0, we know that that function is a factor. Okay, so the question here says, determine whether 2x minus 5 is a factor. So I'm going to take 2x minus 5, and I'm going to solve for x. You can use decimals if you want. You don't have to use fractions. So 5 divided by 2 is 2.5. So I'm going to do f of 2.5 into this function. So 3x cubed plus 2x squared. What else? Minus 3x minus 2. Minus 3x minus 2. So I'm going to plug this in, and if I get 0, I know that 2x minus 5 is a factor. If I don't get 0, I know it's not a factor. Okay, so let's see what we get. Power 3 times 3. So I'm just going to type it into my calculator. And then let's add it up. And we get, so since I did not get 0, I know that 2x minus 5 is not a factor. Okay, not a factor because I didn't get 0. So that's where it's useful. Okay, that's where it's useful to find out if it's a factor. So let's go back to this one, f of 1. If I want to know if x minus 1 is a factor of this polynomial, and I don't want to do this long division, so let's write out the polynomial again. So I want to know if x minus 1 is a factor. So let's write that out. Is x minus 1 a factor of f of x? So I'm just going to do f of 1. So I'm just going to put in 1 into the equation here. And let's see what we get. So we get 1 plus 6 plus 3 minus 10. I get 0. What does that tell me? That tells me, yes, x minus 1 is a factor. That is a factor of that polynomial. Okay? So that allows us to factor these polynomials without actually doing the long division. We can just plug in numbers to see which ones give us 0 and determine the factors that way. So then the question is, well, how do we know which numbers to try, right? Because it seems kind of random. Well, the numbers that we try are based on the number at the end, 10. Okay? So how do we know which numbers to try? So we look at the constant. So in this case, it's 10. So I'm going to use multiples of 10, any number that divides into 10 evenly. So I could try 1 goes into 10, right? 10 divided by 1 is 10. 2 goes into 10. 10 divided by 2 is 5. 3 does not. 4 does not. 5 does. 6, 7, 8, 9 don't, and 10. So I could try 1, 2, 5, and 10, and also negative 1, 2, 5, and 10. So I could try plus 1 or minus 1, plus 1 or minus 2, plus 1, plus 5 or minus 5, and plus 10 or minus 10. Those are the numbers I can try. Okay, these are my options. So we already figured out that 1 gave us 0. So we know x minus 1 is a factor. Because it's power 3, there are 2 more factors. So we have to try 2 more. So our option is, well, once I know 1 factor, so let's say the question was factor this polynomial. So I have lots of options to factor this now. I can use my factor theorem along with my remainder theorem and find a 0, which I just did. I found out that f of 1 equals 0. Therefore, x minus 1 is a factor. I could continue to do that. So I could keep trying numbers to get 2 more zeros. Or I could do long division with x minus 1. Or I could do synthetic division with x minus 1. So that x minus 1 starts me off, right? That gets me started on the factoring. So I could now do long division because I know that x minus 1 is a factor. So I'm going to do my long division. So I would need x squared gives me x cubed minus x squared. So 0, 6 minus a negative 1 is a plus 1, so 7. Bring down the 3. Plus 7x gives me 7x squared minus 7x. subtract. So 3 minus a negative is a plus 7, so that gives me 10x. Bring down the last number, so plus 10. And I know that I'm going to get a remainder of 0 because I already knew that x minus 1 was a factor. If I don't get a remainder of 0, either I've made a mistake and x minus 1 is not a factor, or I made a mistake in the long division. So what do I have left now? I have one factor, and now I have a quadratic. So I know how to factor quadratics. So now I know x minus 1 is a factor, and the quadratic I have as the quotient is x squared plus 7x plus 10. And I can factor that because it's just a simple trinomial. And now my polynomial is factored. Okay, so just by finding that first factor, I was able to then do long division to finish the factoring. Or I could try other numbers, if that's your preference. So like we said, we could try 1, 2, 5, and 10. Well, you'll notice that 5 or negative 5, so there's my 1. Negative 5 would give me 0, and negative 2 would give me 0. And I would be able to figure out the factors using the factor theorem. So lots of different options to factor these polynomials. I'm going to do one more. So let's find, let's see. So I'm just going to write one out here. What time is it? Okay, so let's say the question says factor this function. So I want to start by finding a 0. So I want to start by finding a number that when I plug it in, it's going to give me 0. What numbers can I try? Well, I look at the constant. The constant is 2. So we can try, well, 1 goes into 2, so we could try positive 1 or negative 1, and 2 goes into 2, so we could try positive 2 and negative 2. All right, we could try those 4 numbers, and we want to get a 0. So I'm going to start with 1. So I'm going to plug in 1 into the function here. You can do this right on your calculator. You don't have to write it out. So 2 minus 3 plus 2 gives me negative 6 plus, so that gives me negative 2. So that does not work. So let's try negative 1. So 2, and we'll plug in negative 1. So we get negative 2 minus 3 plus 2. Well, that gives me 0. So there we go. I found a 0. So this is going to get me started. So since f minus 1 is equals 0, let's write that out here, then x plus 1 is a factor. Okay, so I found a factor. I could try and find another one using the same process. Okay, I can try 2 and negative 2 and see if I get another 0. I could keep doing that, or I could do the long division, or I could do synthetic division. Once I have that one factor, I have options, right? So I'm going to do synthetic just for practice. So I'm going to write out the coefficients. So 2, negative 3, 2. I'm going to bring down the 2, and we're going to divide by the root. So negative 1, right? We're dividing by this, not the factor. So we multiply. Negative 1 times 2 is negative 2. We add. Negative 1 times negative 1 is positive 5. We add. Negative 1 times 2 is negative 2. We add, and we should get a remainder of 0. And that confirms that that is a root. So what does that mean? That means that x plus 1, right, is a factor. And then this is my quadratic that's left over. And then I can factor that because it's a quadratic. It's a harder one, but I know how to factor those. So whatever method you use to factor, you can then do the quadratic. So now it's factored, right? So I was able to find 1, 0 by substituting in a value and finding 0. And then once I had that one root, I can either do long division with that factor, I can do synthetic with that factor, or I can continue on with the factor theorem and see if I can find another 0. I see here x minus 2 is a factor, so if I had done f of 2, I would have found another 0. Okay, so that's the third option for factoring. Don't panic if you are totally lost right now, because we're going to do some more, and we're going to look at it again next week, right? We just have to finish this unit, so we've got time. So that we'll get those started who are working on that. And we will do some more practice of that next week because it is an important topic. Advanced